Good morning, everyone. Thank you very much for joining me today. This is Ben Keyser with Applied Flow Technology, and I hope that everyone is having a very fine week and happy beginning of the month of August. Today, I'm going to be talking about a introduction to AFT Fathom. And so, if you have never used AFT Fathom before, then this will give you a good overview of how you can start getting into the software and working with things. So at the end of the webinar, you'll have a pretty good idea of how to get started once you open the software. If you are listening in and you are an existing user, then you'll probably learn a few tips and tricks here along the way. And so I think it'll cater pretty well for both audiences of new users and existing users alike. I want to let you all know that this webinar is being recorded, and that way after the webinar later this week, you will be sent a link so that you can watch the recording again later if you want, or you can pass the recorded webinar on to your colleagues. And I also want to inform everyone that there's a few handouts available with this webinar. There's a data sheet on Fathom. There's some information. I also included my presentation PDF as a handout for the webinar. So for those of you who are listening in live right now, you'll have access to my webinar presentation immediately. For those of you who are listening in on the recorded webinar, if you email me at benkeyser@aft.com, I'll be happy to send you a copy of the presentation as well. My email address is benkeiser@aft.com. I'll give that email out again at the end of the webinar as well. All right, so jumping in here, a couple of important things I want to talk about first before we get started. If you have never used the software before and you want to play around with it, how do you find a demo? Well, our website is the best place to find things. And so I'm going to pull over a web browser here. If you go to aft.com and then under downloads, click on free demos, here's where you can download any of our demos. That way you can play with the software. You fill out a form and that way you'll be able to get access. And if you have troubles downloading them, or if you don't get the demo, email us and we can help get you up and running with the software. The demos are intentionally limited. These are 3 different options of how you can model a system for the demo modes. You can change between any of these options at any time for the demos, so you're not locked into only using one. You can use any of those demo options and switch between them as you're playing with the demo, and the demo version is not time limited, so it'll give you a really good look and feel for the interface. Next thing, how do you find the full version of the software? Well, if we go back to that web page under downloads, go to current version, here's where you can find all the current versions of each of our products. AFT Fathom 10 can be downloaded right here. This will tell you the release date of the latest release of the software. You can download the current version here. This is where you can find the release notes. And then down below, you can sign up for notifications. That way, whenever we post a maintenance release, you'll be able to get those so you can get the latest and greatest updates on that. Next thing, I just did a Fathom 10 new features webinar last week, and I highlighted all the features of the latest version really well, and it's available. Where can you find that? If you go to our Learning Center on AFT.com, I'm sure that you all are familiar with where to find the upcoming webinars, but if you go to the webinar library, this is where you can go through and submit the form here and fill out that list of information. And then here's your webinar library where you can gain access. So if you go to Watch Now for AFT Fathom, then here's where you can find the Fathom 10 webinar that I did last week, right up there. So that's our Fathom 10 webinar. Just a few more items. AFT Aero 7 was released last week. So if you are an AFT Aero user, be sure to make sure that your support upgrade and maintenance agreement is current. That way you can get upgraded to the latest version. It's got a lot of really good features in there. How can you find our case studies? All of our case studies are on our website under the Learning Center. Go to case studies. We've got over 40 of them for Fathom, Aero, and Impulse. These filters can help you narrow down specific case studies that you might want to look for. Categories, we've got good case studies that correlate to test or field data, other case studies that promote operational benefits and sustainability, etc. So that's our case studies page. Next on the list is our tips and tricks blog articles. That's a very important page to make sure that you visit, and you visit often, because we're constantly adding new content. If you go to Learning Center, tips and tricks, this is where you can find all of our tips and tricks articles. That way you can learn how to use the software more effectively and efficiently. And a lot of these articles all start out from technical support questions. So common issues that people are dealing with, here's where you can find those. So those are some housekeeping items I wanted to cover. How's the software validated? Well, one thing, obviously, our case studies. We've got over 40 of them. People are using the software in their specific industrial applications, and it's working for them. They're matching their model results to their measured data. It's helping them solve problems for their pump and piping systems. And so that's an excellent way that the software has been validated. The next way is through our software verification cases. If you browse on your computer after installing either the demo version, the free viewer, or the full software itself, you can browse to your AFT application folder, and then there's a verification folder within each product. The verification folder is where you can pull up the file that contains a summary of all of our verification cases. I actually have that open, so I'll go to it really quick. Here's the verification file, and this contains several cases where we have built models of, I think I'm looking on that on a network. I'm not sure why it's not displaying. So here's a good example. This is a case that verifies NPSH calculations. So we've listed the reference of where we're building a model, and you can see what the model looks like. This is the model of that system. And then we run the model, and we do a results comparison between the resource, which is Cameron in this case, and AFT Fathom. And as you can see here, the results are spot on, and we list any assumptions that we made, as well as our discussion of the results. And we've got 76 of them for Fathom. We have very many for Aero and several for Impulse as well. So you can go through all of these cases. You can read. It contains a picture of the model for every single one of them. And then if you actually browse to that folder, we've also included all of the verification models. That way you can open any of these up and run them yourself. Lastly, one of the other best ways that our software has been validated is through our nuclear verification and validation program. Archon Engineering is a third-party organization that did a full-on verification and validation of each of our products, AFT Fathom, AFT Aero, and AFT Impulse. They've pretty much double-checked just about every calculation to ensure that the calculations are being done correctly. This allows the software to be used in safety-related systems in the nuclear industry. So, this, definitely goes to show a significant quality assurance of each of the products. So that's where you can find those pieces of information. Okay, trucking right along here. I'm not going to go through these first few slides. This is all stuff that I would, go through if I had more time. But since I have made the presentation available, I'm going to skip several slides. These are all of our products here at AFT that we offer. You can find more information about each of those on our website by going to products and then AFT software overview. and then here's where you can see a summary of each of them, and then you can click on any of those and get more details there. So I'm going to skip all the way ahead to this slide right here, and we'll pick back up. So I've just started Fathom. What do I do now? The primary goal is to make the red light turn green. So that's the red status light right there. We want to make that turn green. That way you can run your model and get results. So with that being said, I'm going to go ahead and jump into AFT Fathom now. Here's AFT Fathom, and so this is where we have our startup window. And as you can see, there are several options available to you before you begin working with your model. You can access currently used files that you might have worked on before. You can browse to our example to browse to a file in the server or something. The example files, those are our models of our walkthrough tutorials that we have built. Other things that you can do is I'm going to change my pen color. You can activate the add-on modules. So if you have any of these add-on modules, extended time simulation, goal seeking control, settling slurry, etc., simply check the box here, and that'll turn on each of these modules, and that'll allow you to work with expanding capabilities of AFT Fathom to work out very powerfully for you. You can set your working fluid and other user preferences from the beginning. And then finally, on the far right-hand side, this is really important. You want to make sure that you're checking to see that you're working with the latest release. If you click on this button right here, it'll take you to our website, and then you can compare this date with the website date. You want to make sure that they're the same. With doing technical support, I've found that about 8 or 9 times out of 10, any time that someone's running into a problem with the software, simply updating to the latest release is the best way to fix those issues. And so that's the latest release. You can subscribe to receive notifications. You've got some access to some help content like our quick start guide, our quick start video on our website. You can access the help files, the example tutorials, etc. Okay, so next thing to do is to click on Start Building Model, and this is how you're able to start building a model of your system. It gives you a tip of the day. You can read a lot of different tips that are really useful. If you're sick and tired of seeing it, you can just uncheck that box and you won't see them anymore, and then click OK, and now you're ready to begin. So what do you do first? Well, again, make the red light turn green. So here's the red status light right down here in the bottom right-hand corner. If you click on this red status light, it's going to pull up our checklist of items that need to be completed before you can run a model and get results. The first option right here, specify solution control, that's the tolerances that will dictate if you have a converged solution. The tolerances are very tight and very robust, and the default values will solve about 99% of the cases. So you're never going to have to muck around with this. You get a check mark on the checklist for free. So you don't have to deal with that very much at all. The next thing is to specify your system properties. That's your fluid information. Well, what's the minimal required fluid information to define? I just hit the F2 button on my keyboard to turn on the blue highlighting right here. So as you can see, the minimal required input, which is indicated by the blue highlighting, simply shows me that all I need to define my fluid is density and dynamic viscosity. That's all that you need to specify your fluid properties. You can change any of these units with the drop-down menu, so any sort of unit that you want to work with is fully supported. I highly recommend entering vapor pressure so that you can know if your fluid is cavitating and do MPSHA calculations. There are other fluid options available. We have about 50 fluids that we've built in for you. They are simplified fluids, meaning they're only functions of temperature. You just select one and add it to the list, type in a temperature, and you can, again, change the units. It gives you a range of valid temperatures, and then you calculate the properties, and there you go. Constant fluid properties will use those values in every pipe in your system. Variable fluid properties right here will use these values by default, but then you can change your fluid properties on a pipe by pipe basis. So if you've got separate pipes that are mixing together right here at this point, you can define fluid A in this pipe, fluid B in this pipe, and then the third one downstream, we've got your mixture properties. So that's what variable fluid properties does, is it allows you to define your fluids individually on a pipe by pipe basis if you want. I'm not going to cover all of these different things in great detail. I'll just highlight them really quickly. If you want to work with more accurate water data, you can use data from the ASME steam tables. The Chempak Fluid Database contains accurate thermophysical properties for about 700 different fluids. They're all in here. They know where the saturation lines are. So if you're doing heat transfer and your fluid gets too hot and it's boiling away, it'll tell you about that. Also, you can click on Create a New Mixture, and you can define a multi-component mixture of all of the different fluids on a mass or mole fraction basis. Once you define your mixture, it will calculate the mixture properties for you, which will save you a lot of time because that can be pretty difficult to do by hand on your own. The Chempak Fluid Database is a separate license that you would have to purchase. So if you want to use the Chempak Fluid Database with Fathom, you'd have to also get the Chempak Fluid Database, and then you can work with those fluid properties. Fathom 10 just included a brand new database. It includes the NIST RefProp database from the National Institute of Standards and Technology. Not as many fluids as in Chempak. There's about 200 of them, but they are very well trusted fluid property data sets. So you do not need a separate license for NIST. The NIST RefProp properties are included right with the standard software. We can work with several different viscosity models, such as different paper stock options. You can do a power law or a Bingham plastic. The really powerful thing here is rather than just entering the constants directly, if you click on Calculate from Rheological Data, you can define your shear rate and your shear stress, and then from that data, the constants will be calculated for you. So if you're doing any non-Newtonian fluid modeling, Fathom is definitely very well in that ballpark for you, and you can model just about anything with that. And finally, you can define your environmental properties, your atmospheric pressures, transitional Reynolds numbers, etc. Now, here's the model that I'm going to build from scratch just to get things started here. It's a very simple system. I've got 3 reservoirs. I have a branch point where the flow paths are connecting together. I've got a control valve, which I'm going to use to control the flow. And what I want to know is what are the flow rates, velocities, and pressures in my piping system. Initially, the flow is measured to be 800 gallons per minute in this particular pipe right here. Okay, and so we're going to use the control valve to help with that, and you'll see how that works shortly. We're going to do another scenario after this first one, and we're going to figure out what's the maximum potential flow that we might have. So this is the system that I'm going to build, and the fluid is, let's call it water at 60 degrees Fahrenheit. So I'm going to move this out of the way over to the side, and I'm going to define AFT standard, water at 1 atmosphere. We'll call it 60 degrees Fahrenheit, calculate properties, and click OK, and there we go. We now have our second checklist item completed, and the next thing is to define all pipes and junctions. In order to define all pipes and junctions, there has to be pipes and junctions. With AFT Fathom 10, we just introduced a brand new drawing mode. It's our isometric grid, so I'm going to choose the isometric drawing form, and I'm going to show the grid, and this is going to help me be able to build my model. So when you build your model, you've got your tools and components over here on the left-hand side. Those are the components that you'll use to define the hydraulics in your system. So I'm just going to start building this. I've got my reservoir junction. Once I have a reservoir junction, I can select it and I can do Control D with my keyboard. That way it'll draw a second one for me really easily. And then I'm going to have a branch junction right down below. And then I've got my control valve. And then finally, I've got my discharge reservoir down here. Okay, so after you go through and you lay out your pipes or your junctions like this, you can double click on the pipe drawing tool, and that way you can simply play connect the dots. So if you draw a pipe from about the center of one junction to the next one, you can draw your pipes. Now obviously I don't like how this pipe got arranged, so I can select it, and then where the arrow lines cross right here at this segment, I can click on that and start dragging. And then as you can see, there's a dotted red line that appears. This gives me a representation of where that pipe will be laid out. You can use either the scroll wheel on your mouse or your arrow keys to change where you put that pipe. And so this is the one that I like, and bam, there you go. So that's how you can quickly build your system. So I've got a pipe here, I've got a pipe here, and then I've got a pipe here. And then for this particular pipe, I'm actually going to change it up a little bit. That's where I want it to go. Perfect. So here's my system. I'm going to make my font sizes a little bit large. The user options window right here is where you can configure all of your different preferences with how you want to work with the model. So these are all your preferences. You can save them as new user defaults. That way, every time you run Fathom, this is what you'll be working with, and that way you can do different things. All right, save and close. So there you go. You can see how my text size is larger. You can move these labels around. That way the labels are not being covered up by the various pipes or junctions. Okay, so I've got my model built now. And again, how do you find the user options? You go to the tools menu and user options, and there it is. Okay, so after you build the layout for your system, you can click on this link right here to define all pipes and junctions. This will do two things. One thing is that it turns on the status light, and it's going to highlight any of these labels for your pipes or junctions in red. That's a visual indicator that those components or pipes are missing some piece of information. So that way you can quickly figure out what you need to define so you can run your model. The other thing that it does is it brings out our list undefined objects flyout panel. Okay, that panel is really useful because it lists all of the pipes that are undefined as well as the junctions that are not fully defined. If you click on any of those, it'll tell you exactly which pieces of information are missing. So the minimum input for a pipe is length, diameter, and friction model. If you were to click on any of the junctions, for example, the control valve, it'll tell you that you need elevation input as well as a control set point. Also, it will select that object on the workspace, and it'll move your workspace to that area. So let's say you've got a model of 500 pipes and junctions, and your model won't run because you're missing a pipe diameter somewhere. Well, it's really hard to find where that piece of information is missing in your system. Well, don't sweat it. All you need to do is simply click on the Define All Pipes and Junctions button, select the pipe that you're trying to find, and then it'll tell you what's missing, and it'll take you to that location on your model. So it makes it very quick and easy. All right, I'm going to define my junctions first. So I'm going to start with my supply reservoir. You can change the name if you want. So I'm going to call this supply tank A. And then you're going to define a liquid surface elevation. Again, follow the blue highlighting. That's the minimal required input. As you're going through this process, you see that the software guides you through every step of the model building process itself. So my liquid surface elevation is 50 feet. Now, where's the pipe connected? You can connect your pipe and define that in terms of the elevation of the pipe connection, or you can base it on pipe depth, which if you do pipe depth, that is going to be measured from the liquid surface elevation down to where your pipe is. Okay, so those are two different ways. I would recommend using pipe elevation. Um, One of the reasons why is because if you turned on the extended time simulation module to do a transient, this window will change and you can model finite tanks. That way you can, in XTS, see how this liquid height changes over time. You'll see your tank drain and fill. Well, the thing is, if that tank level is draining or filling and you've used pipe depth, that pipe depth is going to be constantly changing, where in reality, your pipe is not going to be changing where it's connected. It's staying put. So that's why I recommend if you use the elevation option, it makes it a little bit easier. That way you can do your XTS and your pipe won't be moving up and down. Now, in this case, I'm going to go against what I just said. I'm going to use pipe depth. And so, actually, no, I'm going to do pipe elevation. So this pipe is going to be connected at a 40-foot elevation. That's 10 feet below the liquid surface. So I've got 10 feet of head on top of this pipe right here. Okay, so now my first object is defined, and as you can see, the label turned black. That means that junction is now fully specified. The next thing I'm going to do is define my second reservoir. We'll call this supply tank B, and he's going to have a 45-foot liquid surface elevation. And in this case, the pipe elevation is 35 feet. And click OK, and he's fully defined. And then the discharge reservoir, we'll call this a discharge pond. As you can see, you can give it whatever name you want. Liquid surface elevation, 20 feet. If it's a tank, you could pressurize it if you want. The pipe depth here, or pipe elevation rather, is going to be at a 10-foot elevation. Now, let's say you've got multiple pipes connected to this reservoir. Let's say you've got another pipe coming off here and another pipe coming off here. You can connect up to 25 pipes to reservoirs. Well, here's the thing. If you have multiple pipes connected, you're going to see this field become active because not all pipes are going to be connected at the same elevation. How do you specify the individual elevation for each pipe? Well, the way you do that is you go to this tab right here, pipe depth and loss coefficients. So if I go to this tab, here's where you can individually specify either a K factor for entrance or exit losses, as well as the individual pipe depth or elevation for each pipe that's connected to your reservoir. Excuse me. Okay. All right, so we're moving right along here. This is my branch junction. He's just a simple connector point, and I'm gonna, he's at a 0-foot elevation. If you want to define losses across this connection, you can by specifying your own K factors here if you like, but by default, this is the simplest way to connect pipes to each other is by using the branch. By default, it's going to be lossless, so no K factors. You could use a T, and you can actually use the detailed T option, and now calculate pressure losses across the T if you want. So if you want to be fancy, you can do that. In my case, I'm just keeping it simple here, which works 99% of the time for you, and we'll just do it that way. Next thing here is my control valve. You can do control valves in several different ways. You can define it as a pressure reducing valve that controls the downstream pressure immediately right after the valve. The pressure sustaining option controls the immediate upstream pressure right here. Obviously, the flow control valve option controls the flow through the valve. Well, here's what we're going to do. In my particular model here, I'm going to use the flow control valve option, And I'm going to use the volumetric flow rate set point, and I'm going to call it 2500. Now, here's the thing. I don't actually know what the flow in this pipe is. So that's a big question mark. I don't know what that flow should be. However, I do know that I am getting 800 gallons per minute through that pipe. 800. Okay, so what I'm going to do is I'm going to specify this as a default set point, and I'm going to turn on the goal seek and control module, and it's going to change. That's a delta for change. It's going to change that set point in order to get 800 gallons per minute through P2. So you'll see how powerful and useful the goal seek and control module is. All right, so 2500 for right now. All right, now that we're done with the junctions, we're going to do the pipes. In order to define your pipes, you just select one and hit enter, or you can double click on a pipe, and that'll open up the pipe property window. All you need is inner diameter, length, and friction model. If you do user specify for the friction model, then you can pick any of these options: hydraulically smooth, Hazen-Williams, explicit friction factor, etc. If you want your life to be a little bit easier, you can select from our list of pipe materials that are already built in. And so I'm going to choose steel pipe in this case, and my pipe size is going to be 10 inches in diameter, standard schedule 40. So that makes it a lot easier to define the pipes by choosing the drop-down menus and picking your material. If there's a material that you need to work with that's not in our database here, it's very easy to create. Your own pipe material database, and once you do, you'll see it in this list. This webinar is outside the scope of showing you how to build a database. I'm not going to go over that today, but if you visit our tips and tricks page, you'll be able to find one of my blogs that I wrote, and I'll guide you through on how you actually build a pipe material database for yourself. Okay, you can also do different geometries. If you did user specified, then you can do different geometries of the pipe, non-cylindrical, you could do rectangular, duct, etc. Okay, so back to this. Steel pipe, and then 10 inches in diameter, and this pipe is going to be 200 feet long. Click OK. There we go. Now, as you can see, there is a right angle segment right here and right here. Now, that does not mean that you have an actual elbow at that location. If you want to ensure that you have the loss across an elbow at that point, there's two ways to do it. One way is you can use the elbow junction, and you can put an elbow right here or right here. That's one way. That way you'll have a K factor across the elbow. The other way is, instead of using the junction, you can go to the Fittings and Losses tab, and then you can go in here and select elbows, and you can simply pick which type of fitting that you're working with, and then put a quantity. So maybe there's one of those in that pipe. He's a 90-degree elbow, and there's your K factor. So this is the other way of how you can account for your minor losses for your fittings without having to model them explicitly as junctions. So this will simplify your model and still maintain a very high level of accuracy. So once I included that minor loss as a fitting in the pipe by lumping it in, this ampersand and sign shows up, and that's a visual indicator that this particular pipe has a fitting or loss defined for it. So that's useful. That way you can see where you have fittings and losses. All right, this pipe here is going to be same diameter. It remembers the most recently used material, size, and type for you. So all I need to do here is define the length, which is 150 feet. And then my pipe right here that's connected to the control valve, this guy is going to be 12 inches in diameter. So I've got two pipes coming together. I need a larger diameter to accommodate higher flows. And this is going to be a 50-foot long pipe. Last but not least, P4 is also going to be 12 inches in diameter, and he's going to be 40 feet long. And I'm going to go ahead and throw another elbow in here as well. So I'm going to go to bends, and I'm going to put another elbow in there. You can do all sorts of other different types of fittings depending on what you have. If you change different types, you'll see how the picture changes. If you double click on that picture, it'll tell you the reference of where we are getting the loss model information for that item. Okie dokie. Look at that. I now have my third green check mark and a green status light. I can run my model, which you would click this button right here, and you can get results. Before you do that, though, you want to get a quick sanity check. And so for that, I'm going to go to the Model Data tab. This contains a, what do you call it? It's a tabular format for all of your input information. So you've got different sections. You've got a general section at the top. You've got piping input information here, and then junction input information down below. I am not currently displaying every single possible input parameter for my pipes and junctions. If you go and click on the Model Data Control button right here, that is where you can configure which piping parameters you want to show, as well as which junction parameters you want to show. So if you want to change control valve parameters, here's where you can select that accordingly. So that is the model data window. There's a notes tab there if you saw. If I open up this pipe and I go to the notes tab, I can type in some notes. Here are some notes. It's just simple text notes. And then let's say for this junction, I can go in here and type in notes, control valve junction manufacturer A. There we go. So you put in some notes, and then you go back to your model data tab. Once you go to notes, you're going to see a conglomerated list of all of the different notes that you have included for pipes and junctions. Also, if you put in scenario notes down here for different scenarios, you'll see those notes as well. I've not talked about the scenario manager yet. I'll get to that here shortly. Okay, if you go to the pipe fittings and losses tab, as you can see, I have defined fittings and losses, and it will contain a summary for those for you. Why are the K factors different? Well, it's because the pipe diameters are different. So it'll automatically take that into account for you based upon the pipe diameter of the associated pipe that you're modeling. I use the model data window for troubleshooting all the time. That way you can make sure you've got unit consistencies. You don't have things that are off by huge orders of magnitude. It's a really good tool. So I would advise that you use the model data window often. Okay, now I am going to go ahead and run my model. And before you run, it's going to force you to save, which is certainly a good thing to do. I'm just going to call it 3 reservoir system. And it's going to run and give me some results. All right. There's 3 different ways that you can view your results. One is with the output window, then the vis report, and then graph results. I'm going to start with the output window here first. So I'm going to go to output. And this looks a lot like the model data window, where it contains your output information in a tabular format. Again, you've got a general section on the top, piping section in the middle, and then junction sections at the bottom. Now, I specified a fixed flow rate in that control valve. That's the flows that we are getting. That's not what I wanted to do. I wanted to make sure that P2 actually has 800 gallons per minute. If you right click and hold on a pipe or a junction, it'll display your input information. If you've already ran your results and you have output, you'll see output results as well. So 280 gallons per minute, that's not the flow that I actually, That's not the flow that I actually have. So how do I get the flow that I want? Using this control valve, which controls the flow right here at that point, in order to get the flow I want here. That's where you use the goal seeking control module. So I click on the button right next to the status light right here. I'm going to check the box for GSC in order to turn that on. All right. So I click on GSC, and this turns on the module for me. Well, I'm doing a couple quick questions. Why do some pipes not show losses? Well, all pipes have pressure losses. And so, as you can see here, you've got pressure losses. They're just very small. Why do some pipes not have fittings? If that's your actual question, it's just because I didn't put them in there. So you don't have to populate this list. You can if you want. I didn't. That's why you don't see the ampersand right here. Another question is, what does relaxation automatic mean? It's not really something that you're ever going to have to worry about. If you want to know, I would advise going to the help menu and doing a keyword search for solution control, and that'll tell you all that you want to know about the solution tolerances. All right, moving right along here. I've got my GSC turned on. I'm going to go to my goal seeking control manager. My variable is going to be the control valve. I'm going to change the control valve set point in order to achieve my goal of a fixed flow rate. So my fixed volumetric flow rate is going to equal 800 gallons per minute, but the location is important. The location is pipe P2. Okay, that's where I'm specifying my flow. So this is how you can do remote sensing capabilities with control valves, is by using the GSC module. That way you can modulate your set point based upon some other feedback. Maybe it's pressure or velocity or temperature elsewhere in the system. And so GSC makes that really easy to do. So I click OK. Now I'm going to rerun this. And now you can see that there's a V here for variable and a goal here, or G here for goal. So that tells me I've got a variable for that junction and a goal defined for that pipe. So now when I rerun this guy, it does it very quickly. I could do it by hand if I want, by constantly changing the flow set point in order to get the flow in that pipe that I want, but just let GSC do it for you. It took not even 3 seconds for that. So now, as you can see here, you've got 800 gallons per minute in that particular pipe. Now, I saw another question come up. Why is the pressure drop negative? That's a very good question. You have negative pressure losses right here. Well, what is going on? If you go back to the workspace and you look at your elevation information, you can see I've got a 45-foot liquid surface elevation here and a 50-foot liquid surface elevation here, and then this branches at 0 feet, okay? You've got flow going downhill. The flow is going down in these two pipes. So when your flow is going downhill, you've got a hydrostatic component that is helping regenerate pressure. So rather than having a pressure loss in the pipe, you actually have a pressure gain. So the pressure right here and right here is higher than the pressure here and here. Simple hydrostatics. So Fathom is taking that into account, all of your standard fluid mechanic principles. It's not doing anything magic. Now, we've looked at the output window here. If you click on the output control window, just like the model data control, this is where you can configure all your parameters that you want to have displayed. You can click on the drop-down menus to change units. You can move the order of these parameters around in the list. Lots of customization available to you in the output control window here. I'm not going to touch very much on that. You can also double click on any of these column headers, and that's another quick way to change the units. If we go to the variables tab here, we can see that your control set point for your control valve actually needs to be 3,114 gallons per minute in order to ensure 800 GPM through that pipe. The best way to examine your results is with the visual report window here. So if I go to the visual report and then I click on the eyeball, that's the visual report control. That's where you would specify which parameters you're going to show on top of the model itself. So what was the question? I want to know what are the flow rates, velocities, and pressures in each pipe. Okay, so I'm going to do volumetric flow rate, velocity. I'm going to turn on my pressures. I'm going to display my K factors, which is my losses for junctions. Now here's the thing, the only junction that has a loss that makes sense is the control valve. I don't have any losses through my reservoirs or my branch junction. So what you could do is go to this tab right here, show pipes and junctions. Well, in this case, I only have one junction on the entire workspace that I want to show a loss factor for. So what I'm going to do is I'm going to select this control valve right here, and after that I'm going to click the invert button. The invert button is really cool because it takes anything that's selected and it deselects it, and then it'll select anything that's not currently selected. Here's why I did that, is because I didn't want it to go through and manually check 4 individual boxes. I just wanted to check one and then flip it. After that, what I can do is in this data column that's colored in orange, I'm going to uncheck the boxes for those 4 items. So as you can see, when you select them right here on the left, you can toggle data on and off. You can toggle numbers on and off. You can toggle names on and off. So I can put my name there. And then when you show this, it's going to do that. Now let me reformat this just a little bit here. What I'm going to do is I'm going to turn off a few things. I'm going to add some more digits. I'm going to make my pipe size a little bit long, or my font size a little bit larger. Make my legend font size a little bit larger, and there we go. Okay, so here's the cool thing, is that I'm only showing my K factor for the control valve. All right. Everything else, I don't have a K factor for reservoirs or my branch. That way I'm not showing them. So what's the flow rate in each pipe? You can see what the Q value is. You can see what your velocities are. So you've got 9.5 feet per second there, 3 1/4, 8.8 feet per second here. You can see what your pressures are. Again, your pressures are larger at the outlets of these 2 pipes because you're regaining pressure due to hydrostatics. Then you can see how your pressure is lost along the pipeline here, and that's your system results. So there you go. Now, the next question in my PowerPoint was, what's the potential maximum flow that we could ever see in the entire system? Well, how would you do that? Well, the way that you would is by taking this control valve and failing him open. Now, before I do, I'm going to make a scenario. So I'm going to use the scenario manager. The scenario manager is one of the most powerful features of the software because it allows you to track any variety of different cases within a single model file. The scenario manager is just like a family tree. So you can have parent scenarios, you can have child scenarios, you can have multiple parents. So maybe you've got parent number 1 and he has 2 kids. So here's child 1, here's child 2, and then maybe you've got a second parent. So these 2 guys are B for brothers, and then you have maybe 3 kids for child 2. So you got C1, C2, C3. Okay, well, these scenarios and these scenarios would be considered cousins of each other. So the easiest way to get a really good understanding of the scenario manager in a basic sense is that it's a family tree, okay? If you make a change in a parent scenario, that change will pass downwards to each of the two or each of the child scenarios if you haven't already changed those child scenario pieces of data. This makes it very efficient to model several different cases within a single model. So here's what I'm going to do. I'm going to create a new child scenario. I'm going to call it max flow. The exact moment that you create a brand new child scenario like how I just did, he is an exact copy of the parent. So if I went back up to the base scenario right here and I made a change to any parameter, pipe diameter, length, friction model, fluid properties, reservoir heights, anything, those changes will pass down to the max flow scenario automatically. Okay, so that's how data propagates. Data always passes from parent scenarios downwards, but if you ever make a change in a child scenario, they will not propagate upwards. That does not happen. Okay, so now what I'm going to do is I've got my max flow scenario selected, so it's highlighted in blue. I've got my green circle. That means that that is the currently active, currently loaded scenario that I'm looking at. What I'm going to do is I'm going to go to my analysis menu. I'm not going to turn off GSC. I'm just going to ignore it. Okay. So that way it's not running the GSC solver. I didn't want to go in here and uncheck the box for GSC because I don't want to lose the GSC parameters in the base scenario. So that's why I ignored it in this scenario. How do you do a max flow case? Well, this control valve is trying to maintain a set point. So the way that control valves work in software is that the pressure loss across that control valve will be changed in order to meet the set point. Once your pressure loss is known and your flow rate is known, Fathom can then calculate what your CV value is for your control valve. And that can help you size regular valves or orifice plates perhaps. So in order to simulate a max flow case, I'm going to take this valve, I'm going to go to the optional tab, and I'm going to fail him open. No control. So when I choose that option for a special condition right here to do fully open, no control, what that does is that will tell Fathom to basically ignore this set point. So that's how you can keep your set point there and still run your model. So it's not going to take that set point. Your control valve is going to be failed open. Basically, your pressure drop or your DP across your control valve is going to be equal to 0. Okay, no loss. At least by default, it would be no loss. That X does not mark the spot, but it means that you have a special condition defined for that junction. So that's what the X means, is it's got a special condition there. All right, so now I run my model here. I'm going to go back to my visual report, and you can see if you were to fail open this control valve, you can see you've got a K factor of 0, no resistance. Your flow rates are much higher, about 4,100 gallons per minute through each pipe, and your total flow being about 8,200 gallons per minute. So that's a very, very high flow for this system that you could potentially have. But here's an issue though. Look at these velocities, really high. 16 and 17 feet per second, 23 feet per second. You've got some significant pressure losses here, and well, not pressure losses. You just don't have as high of a pressure gain at the bottom of the hill there, but you do have more significant pressure losses in these pipes. So that's how you can use the scenario manager to get different flow rates. If you want to compare results from different scenarios side by side with each other, is go to the output window, and then on the output control tab here, you can go to the multi-scenario section. Here's where you can display results of multiple scenarios at the same time. Click OK. It'll automatically color codes to your scenarios. So this is really powerful because it allows me to compare my results of pipe number 1, base scenario to max flow scenario. Pipe number 2, base scenario to max flow scenario. So here you can very easily compare your different results. Sorry about that. I must have said something that my Apple iPhone Siri thought that I was talking to her and I wasn't. Okay, sorry about that. So as you can see here, this is a very quick and easy way to be able to compare all your results of multiple scenarios. Very powerful feature there. Okay, we've got 5 minutes left here. I can see that I've got one more question that came in. Let me read that really quick here. Because the 2 tanks that fed the system have different levels, there is a chance that the higher feed over the other one is lower. How do you prevent that? I don't know if I completely understand your question, but what I think you might be saying is what happened, or, how do you prevent flow from going this way? Okay, the way that I've drawn my pipe is for flow to go downwards, and if you look at the results in the visual report, you would see positive flow. That means my flow is actually going downhill. Well, that is a good question. I think I'm going to address it the best way that I know how, considering if I understood what you were asking. Let's take this reservoir and actually, let's take this reservoir and let's move them down to a 30-foot elevation. And I'll put my liquid height at 20 feet. Let's see what Let's see what happens. Nothing. Let's go back to my base scenario. Here's where I know that it should happen. So my base scenario, I'm going to take this down to 35 feet and make him be 25. And I'm going to ignore GSE. And so I'm just going to keep that control valve. I'm going to fail him open. Nope, still not expect. Anyway, what I was expecting to see, because I did this earlier, but apparently I've changed something that when I was doing my previous analysis, is if you had reverse flow in that pipe, what you would see in your results is you would see a negative flow rate. So the negative flow rate would be a negative value. All right. And so that's not really a problem. It just means that your flow is going backwards. However, if you have fittings in that pipe, sometimes the losses through your fittings can depend on flow direction. So your fittings and losses may not be as accurate. It shouldn't have a huge effect, but it might cause a little bit of slight differences. The other thing is, if you are using the extended time simulation module, XTS right here, let's just go ahead and turn that on real quick. Once I turn on XTS, you can see how the window changes. I now have these 3 options. If I did a finite tank right here, you can define all of your tank's geometry and your tank height. So in that case, if you had reverse flow, then absolutely you could see your tank overflowing, and that'd be a major problem. You wouldn't want that to happen. And so yes, that'd be a major issue. You can capture that with XTS very, very well. Okay, so that just about closes us up. Just a few closing statements that I want to make for today. An hour is hardly any time to be able to cover very much information at all. So I've barely scratched the surface. What I want to recommend for you all is to keep registering for our webinars. Make sure that you keep registering for upcoming webinars. Be sure to check out our webinar library, and that's a great way to continue to learn more and more information. As you've seen here today, whenever you register for one of these introduction webinars, these are geared for new users a lot of times. So it's very basic stuff. I'm introducing you to the software and giving you an overview of how to use it, or giving you an overview how to use the modules, okay? So if you're an advanced user, you'll learn some new tips and tricks, but it may not be the webinar for you. Other webinars like this are more detailed and they go into a specialized topic. If you want to go over some topics of your choice, or if you have some questions that you're curious about, or you want to see if our software has the capability of modeling certain circumstances that you're dealing with, then call me or email me. My email address is benkeyser@aft.com, and I'll be happy to discuss any questions with you that you might have. If you want to set up a personalized web demonstration to go over something, let me know. I'll be happy to arrange that as well. I'll send you a GoToMeeting invitation and we'll connect. And that way I can do a more detailed and a more specified live demonstration for you to cover the specific questions that you have and to go over more features and capabilities. So thank you all very much for your time today. I hope that you all enjoyed the webinar, and hopefully you are all more familiar with our website and where to find important pieces of information. Again, any questions, don't hesitate to contact us, and keep an eye out for the recorded webinar, and I look forward to seeing you all in future webinars. Take care, everyone, and I hope that you have a wonderful day.